So functions and secretions of the pancreas. Let's have a quick summary of what we've covered so far. So we looked at the pancreas functions, main functions being digestion and to provide a good environment. The structure of the pancreas with the acinar cells forming the acini, and the lobules with the central acinar cells, the ductal cells lining the ducts. I had a look at the ductular network with the various ducts leading towards the main duct. And then the main duct coming and joining the common bile duct at the swelling called the ampulla ovata, surrounded by the sphincter of Oddi muscle to prevent the reflux, and the foregut midgut division by the major papilla. Looked at the two main cells of the pancreas exocrine function, so the pancreatic acinar cells with the polarized end of the zymogen granules and the mitochondria and ruffia to help the exocytosis, and the pancreatic duct cells with the mitochondria. Looked at the role of the acinar cells, main role being digestion using lipases and zymogens, as well as pancreatic amylases as well, actually. We learnt that there's always low levels of secretion when unstimulated through constitutive PKC secretory pathway, and learnt that acinar cells are primarily stimulated by acetylcholine and cholecystokinin from duodenal I cells through the PKC pathway, as well as secretin and VIP through the adenyl cyclase PKA pathway. Learned that the cholecystokinin comes from as a result of luminal cholecystokinin releasing factor not being degraded due to digestive enzymes, so fat prevents the luminal cholecystokinin factor from being degraded, so it can stimulate the CCK release from I cells, which can then go on to stimulate the acinar cells. So you can see that here, so fatty meal and luminal cholecystokinin releasing factor causes CCK release, causing acinar cell stimulation to release its zymogens and lipases and pancreatic lipases. Looking at the pancreatic duct cells, what do? Well, they secrete bicarbonate essentially, which neutralizes the acid and provides an optimal pH for micelle formation, and they're stimulated by secretin. How do they do this? Well, secretin stimulates the CFTR channel. This allows chloride to leave the duct cell, and then when it enters the duct cell again through the chloride bicarbonate exchanger, the bicarbonate can be secreted. So essentially secretin stimulates the CFTR channel, so chloride can leave, re-enter by the chloride exchanger, and the bicarbonate can be secreted from the duct cells. What can go wrong? Well, the cystic fibrosis results in a mutated CFTR channel, so the bicarbonate in water secretions, there's less of them from the duct cells, damaging the pancreas because of the build-up, causing steatorrhea, which is from malabsorption, as well as diabetes. The overall pancreatic juice composition is therefore inactive zymogens, some digestive enzymes in an alkaline environment. And the goblet cells, not only do they have a mucus-producing lubricating function and protection of the epithelial cells, but they also have an immune function. In the fed state, the pancreatic secretions, the rate of the secretions as well as the composition changes. In the fed state, you have high bicarbonate and low chloride due to the chloride bicarbonate exchanger. The thing that inhibits the pancreatic secretions is somatostatin. The way it does that is through I cells, less CCK, so there's no acinar stimulation, as well as inhibiting S cells, so there's less secretin, no duct cell stimulation, so there's less pancreatic secretions as a result of somatostatin. And look, the phases of secretion, so the cephalic phase due to the sight, taste and smell, causing vagal stimulation, and then when the food enters the stomach, it's the gastric phase. Gastric distension causes the vagal gastro and pancreatic reflex, and the amino acid stimulating the G cells, causing pancreatic secretion. Then when the food goes from the stomach to the intestines, then the chyme, well, it's got acid and lipids. Acid causes secretin, lipids cause acinar cell secretion, and this is the intestinal phase which makes up for most of the secretions. The pancreas, it makes inactive enzymes which are zymogens, such as trypsinogen, which are then activated, and then trypsin activates the other zymogens. It's co-packaged with enzyme inhibitor SPINK1. It's condensed with a low pH, and the granules are impermeable. This prevents autodigestion. And when this mechanism fails as a result of get smashed, gallstones, ethanol, and various other causes, then it results in phase 1 inflammation, phase 1 activation, phase 2 inflammation, phase 3 inflammation, causing 3 features, 2 of which are needed for diagnosis. And if it's very severe, it'll cause systemic sepsis and multi-organ failure, and it's treated using either supportive treatment or severe intensive multi-organ support. It could also be chronic pancreatitis due to chronic alcoholism, cystic fibrosis, hypercalcemia and hyperlipidemia, causing permanent inflammation, chronic pancreatitis, leading to diabetes and pancreatic calcification, which can be picked up on imaging. Treatments, you're not going to be producing the pancreatic enzymes, so you're going to need the enzymes, nutritional support, hydration, pain management, and also endoscopic retrograde cholangiopancreatography, which enlarges the ducts, places a stent, and drains the pseudocysts to remove either gallstones or remove the calcification from the pancreas.